Sample problem 3.3. A monkey throws a coconut from the top of a coconut tree at a vertical height of 15.24 meters with an initial velocity of 8 meters per second at an angle of 25 degrees below the horizontal. How far from the coconut tree's base, directly below where the coconut was thrown, will the coconut hit the ground? So at the initial position, y naught equals 0, v naught is equal to 8 meters per second, and alpha naught is below the horizontal, so it's negative 25 degrees. Of course here, t naught equals 0. For the other given, just before the coconut hits the ground, we have here the y sub f, negative 15.24 meters. Negative because y sub f is below the starting point, and we are to solve for x sub f. So using 3.5 to solve for x sub f. xf is equal to v naught cosine alpha naught times time. We clearly see that we still need to solve t, since we have v naught and we have alpha naught, but we don't have the t. Recall that in our derivation, we have elapsed time. It's actually tf minus t naught. And here we let it equals t. And so we have, so for t, we use the other equation. We use 3.7. We have 3.7 y final is equal to v naught sine alpha naught times time plus 1/2 gt squared. So since the unknown here is time, we can see that this equation can be solved using the quadratic formula. Thus, we need to transpose this equation into the standard quadratic form. Transforming the equation, this one, to standard quadratic form. Standard quadratic form is 0 equals ax squared plus bx plus c. Here we have let x equals t. So this is we let this one x, let x equals t. So we transform this now to standard quadratic form by equating it to 0. We will transpose the terms on the right to the left side of the equation. So copy yf on the left side minus v naught sine alpha naught t minus 1/2 gt squared equals 0. We rearrange this one so that it will look like the standard quadratic form. So I will just swap the entire equation. 0 equals, and let's write this one first, the one with the t squared, negative 1/2 gt squared, and then this one, the second term, minus v naught sine alpha naught times time plus the last term is the yf. Okay, so now you'll extract the a, b, and c values. So ax squared negative 1/2 gt squared. Okay, remember that this one is our x or t. So that's t squared. So a should be this one. A t squared. Okay. So a is equal to negative 1/2 g. Next term, plus bx. We have minus vo sine alpha naught t. Okay, so plus bx minus, so this must be our b. bx bt. Okay, bx bt. So b is equal to negative v naught sine alpha naught. This is our b, and this is our a. Ax squared bx. Then last plus c, so plus yf, so yf. All right, we now substitute the given. In other words, a here is negative 1/2, g is negative 9.8 meters per second squared. Using your calculator, negative 1/2 times negative 9.8, you should get 4.9 meters per second squared. For b, that's negative v naught is 8 meters per second. Sine alpha naught is negative 25 degrees below the horizontal. Using your calculator, you should get an answer of 3.38 meters per second. And our YF is the given negative 15.24 meters. All right, so we now have our ABC. We can now get the T. So using the quadratic formula, we have X is our T. T equals negative B plus minus square root of B squared minus 4AC all over 2A. Plugging now ABC, we have negative, our B is 3.38 meters per second. 3.38 meters per second plus minus B squared, that's 3.38 meters per second squared minus 4 times A is 4.9. This is a square root sign. Meters per second squared times C. C is this, the YF, negative 15.24 meters all over 2 times A. A is our 4.9 meters per second squared. So this point, you obtain two answers of T. The first T, or T sub 1, is obtained when we use the addition operator. The addition operator in the plus minus of the upper, the numerator. This one, use the plus. The second time, T sub 2 is obtained when we use the subtraction operator, or negative of this plus minus. So let us simplify this one a bit first. Okay, using your calculator, I'll copy the first term, plus minus. Using your calculator, extract a square root of 3.38 square minus 4 times 4.9 times negative 15.4 meters. You should get an answer of 17.61 meters per second. Okay, and I'll copy the denominator. 2 times 4.9 meters per second squared. All right. Executing the plus of this plus minus sign. So minus 3.38 plus 17.61 equals divided by open parenthesis 2 times 4.9 close parenthesis equals. You should get an answer of 1.45 seconds. And for T2, using the minus of this plus minus sign, execute negative 3.38 minus 17.61 equals divided by open parenthesis 2 times 4.9 close parenthesis equals. You should get a negative answer, negative 2.14 seconds. So we are to choose the final answer between T1 and T2. Our answer is the positive. We choose the positive time T sub 1 as our final answer. We choose this positive T because time always moves forward. This means that in this problem, the elapsed time T must be greater than initial time T sub 0, which is 0. The negative time is a fictitious time, or it does not exist in our situation because we started our derivation from T naught equals 0 to some final time Tf, or elapsed time T. Now that we have the coconut's total time of flight, we can now obtain the horizontal distance x sub f from the coconut tree to the point where the coconut touches the ground. We have xf equals, I'm just rewriting our equation, v naught cosine alpha naught t. So we now substitute. V naught is 8 meters per second. Cosine negative 25 degrees. And the time is 1.45 seconds. 8 times cosine negative 25 times 1.45. You should get an answer of 10.51 meters. Thank you for watching.